All right, let's begin here. So this is 1.7. I should write it on here. So this is homework 1.7. It is number 5. It's A, B, C, D, E, F, G. So we've got a long ways to go here. So let's go for it here. So I made some graphs here that we can look at. And we are trying to do a transformation based upon what A. So let's do A over here. This transformation based upon what A says. All right, so if you have the 2, a plus 2 all the way at the end of the number, that means this is a vertical shift. We are shifting this 2 units up in each one of these pieces. So it looks like this little 4, 2, it's going to go up to 4, 4. Notice what happens if we do vertical shifts, just the y value change. Add 2 to this one makes a 3. Add 2 to this one will bring it up to 2. This one should bring it up to a 1. So then let's go with it. So 4, 4 should be our first point right here. I don't know if you want to label these or not, but as long as you're putting them in. So 3, 1 gets shifted up 2 units. So that makes it, so the 3 is here. Looks like it's going to go, this is my original one. So it's going to go 1, 2 up. There's my next one. And then this becomes 1, 2. So 1, 2. And this is 0, -1. So it goes up to 0, 1. So let's see if this is drawn similarly. So it goes like that. A little bit of shift this way a little bit, and then drops back down. So there's our answer. If you want to label these, that's fine. So you're going to go 3, 3. This becomes a 1, 2. And this becomes a 0, 1. So there's your labeling for each of those. Okay, so let's jump to the next one. Part B now says we are going to do this piece here. So a -2 inside, that means we have a horizontal shift. We talked about this in class, a horizontal shift. And it's 2 because it's x -2, it's 2 to the right. So now we're shifting everything this way 2 units. So now it's really the x that changes now here. So it's really a +2 to the x here, +2 there, a +2 here, and a +2 right there. Each one of those get added to 2. So 4, 2 now rests at 6, 2. And 3, 1 now is sitting at 5, 1. Let's see, 0, 1, 0 now rests at 3, 0. And 0, -1 now rests at 2, -1. Okay, so the form should be exactly the same, as it's like a diagonal down, slightly less diagonal, and then again diagonal down. Label these points as we have them. Hopefully you guys know what those numbers are. Those are all 6, 2, 5, 1, 3, 0, and 2, -1. All right, next one, C. All right, that little 2 in front, what happens here? This is a vertical. Now this is a stretch. So we'll be stretching away from the x-axis. That's what we want to do. Stretching away from the x-axis. And so now what happens here, it's the vertical. Notice we're not adding 2 anymore. We're going to be multiplying by 2 here. So it's the y-coordinate being multiplied by 2. Here, when you multiply 0 times 2, it'll still be 0. So that does not change anything. And that should be multiplied by 2. So let's go for it. 4, 2 now stretches out to 4, 4. So this one has went up. 3, 1 now stretched up to 3, 2. Okay, 0, 1 stayed in the same exact spot, because if you stretch away from the x-axis, you're already on it. You're just going to stay on it. So 0, 1 stays. All right, and then 0, -1 multiplied by 2 along the y-axis brings it down to 0 and -2. So there it is, connecting the dots together. Diagonal, that's diagonal, diagonal. So it's really just making sure that we know which of those factors move things. Okay, so now the question is, what happens when you have a negative outside the function and front multiplying it? What does that will give us? That is a vertical reflection. And we say it's across the x-axis. So all these dots, the 4, 2 is going to come down here. That should come down here. Notice also the reflection about the x-axis. The 1, 0 stays in the same spot, and this one should just jump up. Okay. All right, so notice what's really happening is that the y value is multiplied by -1. Essentially, that's what's happening. So -1 times -1 gets you a positive 1. So let's go for it here. So I got myself a 4, -2. I got myself a 3, -1. I got myself a 1, 0 staying in the same spot. And the 0, -1 jumps to a 0, +1 this time. So there's my graph. Looks like that. All right. And you should probably put in the coordinates here, whatever those coordinates are, if it's not clear. Should be a minus, minus. That becomes a 0, 1. And how about a, okay. All right, D is done. All right, take a look at it here. What happens if we're adding 3 inside the function? Well, that's very, very similar to B. That is a horizontal shift. And this time it's going to be to the left. So 3 units left. All right, so in this case, it's going to be the x coordinate being shifted over this way. So that'll be a -3 each time for the x coordinate. So -3 there, -3 there, and -3 there. Let's see where we're going to end up. So that bottom value there, 0, -3, now shifts over to -3, -1. 1, 0 now shifts over to -2, 0. 3, 1 shifted over. 3 units now becomes 0, 1. This one just shifting over. And then this one shifting over. It becomes 1, 2. So there it is. Should be a graph that looks like this. If you got those points, that's cool. Next. What happens if you have a negative inside the function? What is that doing to the function itself? All right, in that case, what we have is we have a reflection. Oh, let me spell reflection correctly. About the y-axis. Or you can say a horizontal reflection, and it is about the y-axis this time. All right, so what happened here is technically all the x values get multiplied through by a -1. So that becomes multiplied through by -1. That multiplies through by -1. So let's see what we got here. So 4, 2 now becomes -4, 2. 3, 1 now becomes -3, 1. And 1, 0 becomes -1, 0. And 0, -1 stays the same because it doesn't move anywhere because it's along the y-axis already. So we're looking for a graph that sort of looks like that. That. Let me draw that a little better here. that, and that. Okay, and last one, G, the 1/2. Okay, so what does the 1/2 do? So inside the function, if you have a multiplier to the x, and the multiplier is a number between 0, there's your multiplier. That's the 1/2 right there. If it is between 0 and 1, you got yourself a horizontal stretch. Now, if it was higher than 1, it would be a compression. So horizontal stretch by a factor of, and here it is, here's the thing, it's a factor of 2, which means you're multiplying everything by 2. Essentially what you're saying is, what should I plug in for x to neutralize that function? So everything just becomes neutralized inside the function itself. So the multiplication would be 2. Or how do you get back to 1? That's what you're doing. Okay, in that case, we are going to multiply the x coordinate out by 2. 2, 2, and 2. All right, so for 2, whoa, I don't even have space for it here. All right, so this should, oh, I don't have enough space here. Should go all the way out to 8. So my fault on this one here. So it should have been 8, comma 2. Hopefully you guys can see that over there. That should be all the way over there. And this should be 6, 1. So that should be like right there. And this should be 2, 0. Should be right there. And it should be 0, negative 1. Still stays. So graph should kind of look like this. It comes down this way and then comes down that way. That's kind of, and then this should have been a little further out that way. Just didn't have space for it here. All right, so hopefully I think that we covered all of them here. Let's see. Okay, that was F, E, T, C, B, and A. Perfect. All right, now we're going on to honor questions here. This would be homework. I have everything over to the left-hand side. This is 1.7, and honor questions were 55, 57, 59, I think. Let me just check. 69 and 71. So let's take a look at those here. So this is us writing an equation. You do have to graph it to verify. This is writing an equation so that it's the parent function and then any changes we do to it here. So let's go with it here. So this one, as I look at this here, it's coming up. What do I see here? So this, first of all, the parent function looks to me like x cubed. That's what the parent function looks to me like. So then the next piece is it, has it been stretched? Has it been moved over? What has been done to this graph? So as I look right at 1, just kind of notice that it's been stretched. Notice that if you look at 1, it bounces up here now. So normally, if you cube 1, 1 times 1 times 1 is still 1. In this case, it is already doubled, so it's stretched out by twice as much. So how do this here? So I think the back of the book writes it this way. Right, so f of x, x cubed is the parent function. So I'm going to do this. I'm going to say then that means the next, so g will include my transformations here. So the vertical stretch of 2 just means this guy would have to be 2x cubed. Okay, next one. Parent function to me looks like it is x squared, right? Because it's a parabola. And so then I notice that, let's see, if that's 4, then that has to be 2 right here. But you notice if you square a 2, it should have been up here already. All right, if we're to plug in f of 2. So first of all, sorry, maybe even better yet here, I see a reflection across the x-axis. So I know there's a negative here. That's just given. But also there's a there's a stretch. Let's see what happens. When I get to 4, I'm at 8 instead of 16. Notice that? If I were to square a 4, should have given me 16 or negative 16. There's a negative there. Squaring a 2 should have given me a 4, but it's only giving me a 2. So it's always half of what I want it to be. So that means I have a vertical compression. So that case would be a negative 1/2 x squared. There's my connections to it. All right, so now looking at this one here, that sure looks like a square root function first. So I'm gonna go like this right here. That's the parent function. The square root function goes like this, starts off at 0, 0, goes that way. Normally it would hit 1, negative, 1, 1. That's the first dot it hits. And then afterwards it hits 4, square root of 4 is 2. Okay, so as we look at this function here, so the question I guess is when is it hitting the 1 value? Scroll across here. Wow. Let's see what else before we do that even. Here, I'm going to go like this here. So because it's going this way instead of the opposite way, so I do have a negative x inside here because it has a reflection about the y-axis. And then, let's see, I noticed that it seems like trying to get the graph here. I think it does that. I think it's right at 2. I think that's where it is right there. No, it's a little bit high. Okay, so right here then, right there, looks like at a negative 4, that's when it hits a 1. At negative 4, it hits a 1. Okay, so what do we do here? So normally, a square root of 1 would hit a 1. And let's see, a square root of 4, I'm sorry, yeah, square root of 4 will become a 2. So notice if I were to plug in, this is a little bit more complicated one here. So notice if I were to plug in a negative 4, the negative of a negative 4, which becomes square root of positive 4, which becomes 2. But I don't want a 2 in that place. I want that guy to become a 1 already here. So what I would have to do this to is to take half of it. Half of 2 becomes 1. Perfect. That works. So there it is. Half of the square root of a negative x would give me all the transformations that are here. Okay, hope that helps. 55, 7, 9. All right, we come to number 69. And we're looking at these two graphs, and the question is, are these identical graphs? Will they produce the same exact graph? So let's graph them, as it says us to do. So I'm going to make my makeshift graph over here. So I'm making myself a little table. You know what? The only thing I don't like about this problem is that this guy, they're both listed the same. We should not have graphs with the same name. So I'm going to change this one to g of x. So x, f of x, and then, we can actually add a third category. Yeah, let's do it this way here. I'm going to just change it to g of x. The two different functions. All right, if I were to plug in a 0 in for x, 0 square absolute value of 0 plus 6 would just give us 6. If I were to add a 1, notice absolute value of 1 is 1 plus 6 is 7. So I add a 2 and I get an 8. I add a 3 and I get a 9. And if I go backwards on this, if I put a negative 3 in, negative 3 here, it's just going to make it positive anyways. So you get yourself that 9. Negative 2 will become an 8, and negative 1 will become a 7. All right, so what did we do? We graphed this. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to be 0, 6, 1, 7, 2, 8, 3, 9, negative 1, 7, negative 2, 8, negative 3, 9. So there's my graph. Okay. If I graph g of x, here's the funny thing that happens. So you plug in a 0, absolute value of 0 is 0, plus 6 is 6. Absolute value of 1, so it comes in like this. It comes in as a -1. But then when you take the absolute value of it, it pops it back up as a positive one, and you get a 7. So notice the same dots again. Seeing a second time real quick here, if I plug in a 2 into the absolute value, that piece will become a regular 2 because it takes away the negative sign. That's exactly what it does. And then sure enough, all these numbers are the same. Therefore, the graph will be the same. -3 still gives you 9. In fact, the -3 is a funny one. So in this case, what happens is you already have a negative inside the problem itself, and a -3 gets plugged in. Oh, no, sorry. That should be a 6. And so in this case, these two become a +3. So absolute value of a +3 is still a 3. 3 plus 6 is 9. So lo and behold, yes, they have the same exact answers, and you get the same exact graph. So it is true. It is true. Okay, the other way to explain it is the fact that this one has a reflection about the y-axis, but you already have y-axis symmetry. So reflection about the y-axis when you have y-axis symmetry is going to produce the same exact graph. There it is. All right. So then let's see where we're at. Management originally predicted that profits from the sales of a new product would be approximated by a graph of the function shown. The actual products are shown in the function g along with the verbal description. So now the question is, can we write these? So instead of being the description of the targets that were there, the profits were only 3/4 as large. When you say 3/4 as large, they're just saying, hey, not up to here. They were down here. So everything was 3/4 as large. So how do we write this? So g of x would be 3/4, because notice that this is just a compression. This is a vertical compression. That's what's going on here. The profits were consistently $10,000 greater than predicted. Hold on, that's a vertical shift in my mind, right? That's a vertical shift. In this case, whatever the profits were, each of those pieces went up by 10,000. All right. There was a 2-year delay in the destruction of the product. So after sales began, profits grew as expected. So now we need to shift over this to the right 2 years. All right, so if we're going to shift over to the right, and remember with horizontal stuff, we need 2 units. With horizontal, whenever you're shifting to the right, it's a -2. If you're shifting left, it's a +2. So in this case, it'll be g of x is equal to f -2. There it is. There's your shifting over to the right 2 units. All right, hopefully this was helpful.